Okay, so let's take a look at an example, and it'll show some of these aspects here. Okay. All right, so let's say we've got this BJT circuit here, and we're going to do some DC analysis of it. We've been told that the base emitter junction is VBE on is 0.7 volts, and that the beta value, the current gain of the transistor is 125. Okay, so let's go ahead and do that. I'm going to redraw the circuit here a little bit bigger so we can write all over it. And so here it is. So there's the transistor. Oh, whoops, sorry. This is actually, so this is plus 5 volts up here. Remember, we've seen this notation before. That means that's plus 5 volts relative to ground. Whereas ground, well, ground is there. The base of the transistor is grounded. And there's a minus 5 volt supply as well. Remember, that's just a node voltage of minus 5 volts relative to ground. So that's 5 volts below ground. This is a 2K resistor. RC, the collector resistor, is 2 kilo ohms, and RE is 4.3 kilo ohms. Okay, and now what we're going to do is, by inspection, we're going to solve this whole circuit. So let's just start writing everything down that we can show, everything that we know, right? So here we're not even going to do nodal analysis or mesh or anything, which we may not have covered mesh by this point in the course. But we'll just kind of by inspection start to write down everything that we know. And we're going to assume that this transistor is turned on. And that's a pretty good assumption because the emitter is being pulled down to minus 5 volts, which means that probably it's not very hard for, if this is ground here on the base, and we have a 0.7 volt drop from the base to the emitter, then what we know is that the emitter, VE is VE, the voltage at the emitter, is equal to negative 0.7 volts. Excellent. Okay. Now, if that's negative 0.7 volts, and this is minus 5 volts, then the difference between those, negative 5 to 0.7 to negative 0.7, is a 4.3 volt drop across that 4.3 kilo ohm resistor. Okay, now we can start writing in everything that that we can fill in. And if I've got 4.3 volts, so let's say we wanted to find IE. IE is the current going through that 4.3 kilo ohm resistor. It's 4.3 volts divided by 4.3 kilo ohms, which is 1 milliamp, a nice round number. So IE is equal to 1 milliamp. Okay, now remember, we want to be able to find all the voltages and currents. That's what we've been asked to find. So if we knew VCE, we could then go and find what VC is, because it would be negative 0.7 plus VCE. But we don't really know what that is. That VCE, we don't actually know what that is. And that could be a variety of things. Without going into the details of how transistors work, it could be a lot of different parameters, a lot of different quantities. So how can we find VCE, or VC rather? And how can we find the collector current? This collector current here, IC. Well, what we're going to do is find the base current, and then we'll know the beta value. Beta times that base current is the collector current. So let's go find the base current, right? So IB is equal to, by what we saw last time on the last slide here, this relationship there. We take the emitter current and divide it by beta plus 1. So this is equal to IE over beta plus 1, or in other words, it is 1 milliamp divided by beta is 125, beta plus 1 is 126. And 1 milliamp divided by 126, it turns out to be 8 microamps. So what we have then is 8 microamps. IB is equal to 8 microamps. Okay, now we know IB, we can go and find IC. We can go and find IC because remember IC is just equal to beta times IB, or that's 125 times 8 microamps, which is, I'm going to actually write this right here. IC is 992 microamps. You see how that's just a little less than 1 milliamp? 1,000 microamps would be 1 milliamp. This is just a little less than that, which is what we expect. So this is 992 microamps. And now if we want to find the voltage at the collector, which we've been writing our voltages in purple, by Ohm's law, we know that this is 5 volts here, and we're going to have a drop across the 2 kilo ohm resistor, which is going to be equal to 2 kilo ohms times that collector current. So this is a plus 5 volts minus the drop across the 2K, right? This is the drop across the 2 kilo ohm resistor, and we're going to write that in terms of the collector current. So this is IC times 2K, or in other words, it's 5 volts minus 992 microamps times 2 kilo ohms. And we find that that is, it's about 3 volts. VC is about 3 volts. Okay, if we wanted to then find the last voltage on this circuit, we could write this down. This is the VCE then is, well, it's 3 volts at the collector. It's negative 0.7 volts at the emitter. So then the total voltage is 3.7 volts.